Okay, so this is our video, our screencastify for section 1.1 on linear equations. So the headings against the left are the actual headings in the textbook. First one's in increments. That's how you proceed through the calculus text. And in there, they remind you that delta y refers to the change in y. And the next heading is the slope of a line, abbreviated by m, and the slope is defined by the change in y divided by the change in x. The third heading is parallel and perpendicular lines. If two lines are parallel, lines 1 and 2, then their slopes are the same. If the lines are perpendicular, then the product of their slopes is a -1. So now we have this template, which we're going to use all the time through the course. We're going to start with a pre-image while we're in linear equations. So we're going to start with the most user-friendly pre-image, y equals x. We're going to do a transformation to that linear equation. It's a slide of hk following, the open circle is following, scale change of AB, where what? Where the h and the a affect the input, the first letters affect the x, and the k and the b affect the y. In order to do this, we're going to do the opposite. So we do the scale change first. We replace x with x divided by a. We replace y with y divided by b. And then we do the slide. And do the slide. To slide the line h units to the right, replace x with x, take away h. And to slide the line up, k units, replace y with y, take away k. And this is 100% correct. Here's just getting y by itself, but you leave this linear equation in this form, it's 100% acceptable. If we look down here, because the pre-image had a slope of 1, this scale change, we refer back to delta y over delta x, the b over a would be the slope of the image, which you see here, we got y by itself. So the first example we're going to deal with in the textbook is on page 5, and that's example 3. And they want the equation of a line that goes through the point 2, 3 that has a slope of -3/2. So again, my pre-image is y equals x. Now, you can do this. If they're giving you the slope, you can make the pre-image y equals -3/2 x and just do the slide. But we're showing this to you with the slope in context of the magnitudes of a and b. So they told you the slope was -3/2, and the slope is b over a. Well, I just said a is -2, b is 3. You could have 2 and -3, as long as one of them is negative only. And then the slide is a magnitude of 2 units to the right, up 3. So we did the opposite, replaced x with x, take away 2, and y with y, take away 3. And again, we're just going to leave the answer in this form. So that's your model. We're going to ask you to pause the video, go to the textbook, page 9, and do problem 13. Okay, so for 13, wasn't really a helpful problem because they're asking you to find the equation of a line that has a slope of 1 and goes through 1, 1. Well, that's kind of silly because the pre-image y equals x goes through the origin. It also goes through 1, 1. Well, what would happen? Well, in terms of the transformation, the slide is 1 to the right, up 1, following a scale change of magnitude 1, 1. So a scale change, when you're doing the opposite, you're dividing by that. You're dividing by the identity element multiplication. That's not going to change the slope of the pre-image. So we have x divided by 1, y divided by 1. Replace x with x take away 1. Replace y with y take away 1. And then when you get y by itself, you'd end up where you started with y equals x. So back to page 5, and example number 4. In this problem, they're asking for the equation of the line when they give you 2 points. So you have to calculate the slope. So here's the t-chart. To find the slope, we just subtracted up. The difference of the y's, 4 subtracted -1. Over the difference of the x's, 3 subtracted -2. And you can subtract down if you wanted. If you subtract it down, you get a negative divided by a negative. You'd still get a slope of 1. Now we got to take this pre-image, y equals x, and slide it through one of those 2 points. So over here, we did the work and we slid it through the point -2, -1 by doing the opposite. We replace x with x plus 2, replace y with y plus 1. And when you add a -1 to both sides, you would get this line. But if you chose this point, you're going to get the same answer because you're going to replace x with x take away 3. You're going to replace y with y take away 4. And when you add 4 to both sides, you're going to get back to y equals x plus 1. You have to get back to the same line because it's going through both points. Okay? So we're going to ask you again to pause the video, go back to page 9, and do problem number 17. So for 17, they're giving us the slope, and they're giving us the intercept. So the intercept, when they say b equals -2, the line's going to the point 0 right or left down 2. Well, they're telling us the slope. So you could have made the pre-image y equals 3x. Or here's the slope in terms of a scale change. And to slide it 0 right or left down 2, we replace y with y plus 2. So if you had y equals 3x, you'd have y plus 2 equals 3x, and you add a -2 to both sides, this would be the equation of your line. So we're going to skip ahead to example 8, which is not to say that you could find something helpful on page 6 in examples 5, 6, and 7, but we're just not going to go over every example. So in example 8, we want the relationship between Fahrenheit and Celsius temperatures, where Celsius is the input and Fahrenheit is the output. So we start with a t-chart where the first line is freezing. Celsius is 0, Fahrenheit's 32. Second line of the t-chart is boiling. Celsius 100, Fahrenheit's 212. So the slope, the change in Fahrenheit divided by the change in Celsius, would be 212 take away 32. Over 100 take away 0 would be 9/5. We want to slide it through one of the 2 points. Well, it makes it more sense to pick the point that has a 0 in it, but you'll get the same equation either way. So we do the opposite. Replace with f take away 32. We're not doing anything to c. You can think of it as replacing c take away 0. And we get f by itself. We would have this conversion that you learned in at ETR. Okay. And if we wanted Fahrenheit to be the input and Celsius to be output, that would be the slope. And then we slid it through the same point, and we get Celsius equals this. So in example 8, it says find the Celsius equivalent of 90 degrees Fahrenheit. So now Celsius is dependent. So I put 90 in for Fahrenheit, 90 for Fahrenheit. And I do 5/9 times that, take away 32, you get 32.2 repeating. And for the AP test in the spring, we're going to round consistently to 3 decimal places. In example 8, they also ask you to find the Fahrenheit equivalent if Celsius were -5. So we're coming back here, we're putting -5 in for C. The 5 would reduce. They give us 9 times -1 plus 32 would give you 23. Okay? So we're going to ask you to pause the video again, turn up to page 10, and look at number 43. So for 43, in the problem, they tell you when D equals 0, the pressure is 1. So we're here, 0, 1. Okay? They tell you 110.94. That's given. So this T chart is given. So it's back close to what happened in the second example we did. So we go up here and we calculate the slope by subtracting up. And then the magnitude of the slide, we just take the top point, 0, 1. So P is dependent. The pre-image is not Y equals X. It's P equals D. The pre-image here for this problem would be P equals 0.0994 D. And we do the slope. Oh, we do the slide. Replace D with take away 0, D take away 0. Replace P with P, take away 1. So we end up with P equals the slope, which we calculated by subtracting up, times the input, plus slide up 1. Then they ask you to find the pressure at 50 meters. 50 is given in between here. 50 in for D, into the equation, and the output is 5.97. Okay? So, thanks for watching our 1-1 video, and we will see you for 1-2 functions and graphs.